ways. Now, to satisfy the Russian judge, this entire thing is timed. Every slide lasts precisely 15 seconds and will auto-advance, so Aaron, you can put the clock away. Like Derek said, I did this last year, and once again, the same as I did last year, all the code with practical journalism examples is going to be available up on GitHub, hopefully in a second. If this thing, it's supposed to be auto-advancing. There it is. Well, maybe I blew that one. All the code is up there. Feel free to take a look. You can also take a look at last year's if you'd like. And this year we're going to do things a little bit different than last year. We're going to go from some stuff that's a little more simple and general purpose onto some stuff that's a little bit more science fiction. And so the first thing we're talking about is this idea of vectorization. Now, vectorization goes by a simple principle that loops in computer programming languages are slow, but matrices are very, very fast. And vectorization is basically changing your code such that you use matrices instead of loops. And what does this buy you? It buys you a lot of stuff. So you want to compare the voting records of every member of Congress to every other member of Congress over a really, really long period of time. You can write a bunch of loops that say, okay, compare this guy to this guy, and so on and so forth, over and over again. And that'll take, maybe half an hour, maybe 45 minutes, depending how far back you're going, maybe even longer than that. Or you can put them all into two matrices, smash them together, and the results will come out in 10 seconds. And so this can be applied to a lot of things. We can do calculations on the fly in our web applications this way to do complex stuff. We can do analyses, all sorts of things. Naive Bayes is number 2. Naive Bayes is a classifier, not too unlike what Anthony was talking about, but it's probably the simplest classifier to understand in machine learning if you actually look at the code to understand it. Now, a lot of problems, as Anthony was also talking about in data cleaning and data journalism, are actually classification problems in disguise. And one of them we dealt with in my previous job at the Center for Investigative Reporting. Augie Armendariz is around here someplace. He did this. Augie had a giant pile of press releases in front of him, I think from the DEA, and he didn't know which one of them, or which ones of them were about drugs and which one of them weren't. And so he basically trained a classifier to be able to tell the difference, and as a result, he didn't have to sit there hating his life reading 10,000 press releases. The classifier did it for him. It's very cool. The next little bit isn't really an algorithm, it's more of a concept or a class of algorithms you see a lot in computer science. You see these for optimization problems, you see it in machine learning. It's this idea of iterative algorithms, which are algorithms that sort of go over and over again in this big loop and refine themselves over time and slightly change their answers and parameters until they zero in on where they're supposed to be. Now there's one particular iterative algorithm that I love, which was done by a Stanford professor back in 2010 called iterative money-weighted averaging. And what it does is it allows you to assign ideological scores to campaign contributors and also to people running for office, even if they don't already have a voting record or something to go on. And so you can ask questions like, were there any conservative donors who donated to liberal candidates? Why might that have happened? Was that unusual? Is that something that we should check out further? It allows you to ask this entirely new class of questions you couldn't before. Vantage point trees are for fuzzy search. And so if you've got a bunch of strings, maybe a bunch of company names out of a campaign finance database, for example, and you need to find ones that are similar for some reason, this is the tool that you would use. And it solves the problem of grown adults who can't fucking spell. How many ways can you spell AT&T? Give me a guess. If you've looked at campaign finance data, you will have seen at least 3 dozen ways to spell AT&T. You can't spell AT&T any other way than AT&T. What you can do on this? Vantage point trees will allow you to say, show me all the stuff that is sort of similar to AT&T so that it all can get rolled up together and you can find out how much money those lack of spelling asshole AT&T employees donated to Congress last year. Latent Dirichlet allocation. What? This is sci-fi. So LDA is a topic modeling algorithm that basically reads documents and assigns to them topics based on sort of collections of words that occur together. That does a lot of things, including solving the problem of millennial laziness. This reads documents in some ways and organizes them so that you don't have to go through and organize. So this big document dump, you want to find out the topics that are involved. Maybe you only want to read documents that are about topic X. You can do that with a tool like this. You apply this to the credit card bill in 2009. You classify every section of the credit card bill with a topic. Most of the topics that are associated with these sections are about credit cards, right? But for some reason, there's also one about guns and national parks. And using this algorithm, you can pluck that out and find out that something weird is going on in that case, which is very useful. Again, if you want to nerd out, that's the spot. The stuff from last year is at the exact same URL, but with 2013 at the end. If you have questions, my Twitter thing will come up in a second. And I will leave you with this. Learn math. Learn computer science. It is not a waste of time. You can do all sorts of cool stuff. And Matt Wake can tell you why you shouldn't be intimidated because he just aced his calculus class.
like a boss.
Thank you.